Hi everyone, this is a review of lessons 4.1 through 4.3. We're just getting into triangle congruence. So there's about 15 questions on this review. I'm gonna walk you through all of them. You can follow along, pause the video, whatever you need to do. The blank notes are included below this video here in this folder. So you can always print those out if you want, but you definitely do not have to. If you're comfortable, or once you're comfortable reviewing all of this, you feel like you know it well, then jump right on into the assignment, and that is due by Friday of this week. Okay, number one, find each measure. So we're finding the measure of angle 1, which is here. We can see this is one triangle. We have a 64-degree angle, a 90, and angle 1, and we know they all add up to 180. So 90 plus 64 plus whatever angle 1 is, all add up to 180. 90 and 64 is 154. Yes, I'm gonna take my time and write out every step. You guys are quick, some of you guys. You can jump right on ahead, but for those of you that do need the extra help, here it is. All right, and then we have to get rid of 154 to get angle 1 by itself. So these go away. And we're left with the measure of angle 1 equals 180 minus 54 is 26 degrees, which is C for number 1. Okay, number 2, this one you have to remember your distance formula, right? That's how we're gonna find all these measures. So it gives us the coordinates. If we were to graph these on a coordinate plane, they would create a triangle. I just skipped that part because I don't need to know where the triangle is, how it's situated to find the length of each side. I do always kind of sketch myself a little triangle just to remember what my sides are. So I have K, P, and L. So first I want to find the length of side KP. Remember, distance formula is x minus x squared. So here for K and P, I have 5 and 3. 5 minus 3 squared plus, whatever order I do the x's in, I got to do the y's in the same order. Y minus y squared, negative 3 minus 4 squared. When I simplify that, 5 minus 3 is 2, and 2 squared is 4. Negative 3 minus 4 is 7, negative 7 squared is 49. 4 plus 49 is 53 under the radical. Did not write out all those steps, but hopefully you know how to do the distance formula by this point. So I just simplified this to get this guy, and I don't need to go further. I don't need to know what the exact number is because it doesn't matter. I'm just comparing it to the others. I'm classifying, I'm trying to figure out if all the sides are the same, if 2 of them are the same, or if none of them are the same. So my next side would be PK, or is it K or L? PL, sorry. PL. And so from P to L, 3 minus negative 1, square root of 3 minus negative 1 becomes 3 plus 1. And then y minus y, 4 minus 1. 3 plus 1 is 4. 4 squared is 16. 4 minus 1 is 3. 3 squared is 9. 16 and 9 is the square root of 25. And of course, we can take the square root of 25, and that is just 5. Okay, and then the last side here, I did KP, PL, now I have KL. And once I have all 3 sides, then I can compare them, okay? So K and L are these first 2 points. X minus X, 5 minus negative 1 becomes 5 plus 1. Y minus Y, negative 3 minus 1 squared. 5 plus 1 is 6. 6 squared is 36. Negative 3 minus 1 is negative 4. Negative 4 squared is 16. 36 and 16 is 52. Okay, so our 3 sides here are square root of 53, 5, and square root of 52. So clearly we can see they're not all the same. So we know we're dealing with a scalene triangle. So we can go ahead and rule out B because it's isosceles. Then we have the other 3 left. So then I want to start comparing. Square root of 65, that's not one of my answers, so I can go ahead and rule that guy out. This guy down here doesn't have any radical signs, right? And there is a difference between the square root of 53 and the number of 53, right? So square root of 53 is talking about whatever number we squared to get 53. So this is not correct. So it has to be this guy, but I did want to take notice of, we have square root of 53, that matches. 5, that matches. But then we have 2 square root of 13, right? And we have scalene, that's what we wanted. but what is this 2 square root of 13? That's not what I got. I got square root of 52. So how do I handle that, right? All I'm doing is factoring and simplifying the radical sign. I just wanted to remind you of that real quick. When we have square root of 52, remember everything under the radical sign, we're finding what number we multiplied by itself to get this big guy. We're actually gonna factor this out, right? So we're gonna come up with all of the smallest factors that we can multiply together to get 52. So I'm just gonna factor until I can't factor anymore. So for me, my brain, simple-minded brain, I always see an even number, so I know I can divide by 2. So 2 times what equals 52? 26. Can I factor the 2? No, I'm done. That's a dead end, so I'm going to circle it. Can I factor 26? Yes, I can. It's even, so I know I can multiply 2 times something to get that. 2 times what equals 26? 2 times 13. 2, we're a dead end. That's a prime number. 13, we're a dead end. That's a prime number. So I can actually rewrite this as square root of, and then multiply all these dead ends together. 2 times 2 times 13, right? 2 times 2 is 4. 4 times 13 is 52. So we're good here. This is the same thing as this, okay? So now I want to pair up any sets of the same number, right? So I have 2 times 2. 2 times 2 is the same thing as 2 squared. And then I still have this times 13 on the end. There's nothing to pair it up with, right? And then rules of radicals say that I can separate factors under a radical sign. I can give them their very own radical sign. So I can say square root of 2 squared times square root of 13. Oops, sorry. Hit my stand here. Darn it, hang on. There we go. Okay, and then, so this is the same as this, whether they're being multiplied under the radical sign or they're in their own radical signs and then being multiplied together, it doesn't matter. But now I have square root of 2 squared. So this square root symbol and this 2, they're opposite operations, right? They're inverses of each other. So they cancel each other out and I'm left with 2. And then I can't do anything to this square root of 13, so it still stays square root of 13. So that's how we got this number from square root of 52. We just kind of simplified it. We factored it, right? Hopefully you guys are familiar with that. That's an algebra review. Okay, and then we have number 3. Find each measure, find the measure of angle 5. Here's angle 5, so I got to look at a few other things first, right? First, I notice I need to know what these other 2 angles are because then I can add them all up and set them equal to 180. So I notice this angle and this angle make up a linear pair, straight line, so they add up to 180. 118 is this angle, so this guy has to be what? 62. Because 62 and 118 add up to 180, which is a straight line, okay? Then I also notice over here, I have 3 angles that add up to a straight line here, right? This 70, this 4, and this 65. 70 and 65 is 135. So what would angle 4 have to be for these all to add up to 180? 180 minus 135 is 45, right? So I've got a 45-degree angle, a 62, and then angle 5, and that's what I'm looking for. So 45 plus 62 plus angle 5 adds up to 180. Combine these two, I get 107 plus whatever angle 5 is. Then I need to get rid of the 107 to get angle 5 by itself. And I'm left with the measure of angle 5 is equal to 73. C. I forgot to write C up here for number 2. Okay, so far so good. Hopefully this is helping. Hopefully you're doing well on your own and you don't need me. You don't have to wait on me to write out the answer. This is just for you to check yourself. The answer, if you just want to skip right now, the answers are all listed in the back of this file. If you haven't, so you could solve it on your own and check yourself if you want. I'm just showing you how I got the answers. All right, the measure of angle 2. This is going off of the exact same picture. So it kind of stinks it's on a separate page, but we're looking at this picture right here. So now we want angle 2. Right? I just figured out angle 4 is 45. These 3 angles add up to 180. 70 and 45 is 115, which means angle 3 has to be 65. And I know that this angle is vertical to this guy, So this has to be 36. So 36 plus 65 plus whatever angle 2 is has to add up to 180. 36, 65, angle 2. And then we combine like terms. 36 and 65 is what, 101? Minus 101 on both sides of the equal, oh, why did I write 181? Because I said 101. Did your brain ever do that? Do stuff you don't give it permission to do, right? 79 degrees, so that's B. Okay, and then I don't know why this little picture got left here. I think there was a question below it and I got rid of the question and the picture didn't go away, but that has nothing to do with anything. All right, and then number 5, construction. The diagram shows an example of the Pratt truss used in bridge construction. Use the diagram to find the measure of angle 1. So we're just finding this guy. Okay, so there's a couple different ways you can do this, right? First of all, we know this is 90, this guy right here. We know these two angles add up to 180, so if this is 45, this guy has to be 35, and then we can add 35 plus 90 plus angle 1 and solve for angle 1. The shortcut you can use is the exterior angle theorem, right? So we have a triangle here, and all we did was extend one of its sides, right? So this exterior angle we've now created is the sum of the remote interior angles. So it has nothing to do with this angle here that it's touching. We're not using this angle. There's 3 angles inside a triangle. We're not using the one this outside angle is touching. But the other 2 add up to this guy. These 2 remote interiors add up to this outside. So angle 1, oh, I just dropped my pen. Angle 1 and 90 add up to 145. The measure of angle 1 plus 90 degrees equals 145 minus 90 on both sides. Measure of angle 1 equals 55 degrees B. Hopefully you remember that and you're familiar with that. All right, and then we have number 6. There's 15 questions total here. I'm trying to move fast to cut down on the time. All right, polygon ABCD is congruent to polygon PQRS. Remember when we say 2 shapes are congruent, the order that they're named in, the letters are in, matters, right? So here it says find the value of X. Well, I see an X here, and I see a Y, and that's the only place. So I see an X here at angle A. So I need to know what to set this equal to, right? How do I know which, I mean, I can like eyeball it, but how do I know which angle this is equal to over here? Well, A is the first letter in this name. P is the first letter in this name. That means these are corresponding angles in congruent polygons. So angle A has to be equal to angle P. 2x plus 4 has to be equal to 100. And we're just solving for X. (45 and 48). And so that would be D. Lots of algebra and geometry. Number 7, classify each triangle as acute, equiangular, obtuse, or right. We have 2 acute angles and 1 90 degree, so this tells us this is a right triangle. Number 2, we've got this little bow tie figure. It says find the measure of angle 3, so this guy right here. Okay, so how can I do that, right? Well, first off, I know all 3 angles have to add up to 180. So is it possible to solve for this missing angle? I know what this one is. It's 35. How about this guy? Well, it's vertical to this guy, and I can find this one because I have the other 2, right? So 58 and 39 would be 60 and 400, 97. So these are 97. So 97 plus what equals 180? This has to be 83, right? And then if this is 83, angle 2 has to be 83 because they're vertical. And so now I can solve for the measure of angle 3. 35, 83, and this guy add up to 180. 35 plus 83 plus angle 3 add up to 180. 35 and 83 is 118. Then I subtract 118 from both sides of my equal sign. And the measure of angle 3 equals 62 degrees. A. Good. Use what you know in these triangles to solve for missing pieces. Sometimes in a lot of these examples, they'll ask you for this angle and you got to find a whole set of other angles before you can get to this one. And that's okay. You kind of expect that to happen. Okay, number 9. Classify each triangle as acute, equiangular, obtuse, or right. So I look at all 3 of these. They are all less than 90 degrees. So this is an acute triangle. This is an acute triangle. I say angle all the time when I'm talking about a triangle. And sometimes when I'm talking about an angle, I say triangle. That's great, right? Not confusing at all. Now we're on number 10. So we got this one and 5 more. Find each measure of angle 2. So we've already looked at this figure one time. I meant to put all these together that were based off the same figure and I didn't. But measure of angle 2. This one's easy because we know this angle is 90. And we know all 3 add up to 180. So 90 plus 58 plus angle 2 add up to 180. 90 and 58 is 148. Get rid of that 148 to get measure of angle 2 all by itself. And the measure of angle 2 equals 32 degrees, B. Number 11. I do feel like on a recorded video I can go faster. I know some of y'all are like, please hurry up, please stop talking and just hurry up and so. But for those of you that think that it's going too fast, you can always pause or, you know, rewind it or whatever, not rewind it, but go back and start over. So I'm just gonna keep moving forward. Measure of angle 1, this guy right here. Well, we already found in another question, I didn't put them together and I should have, we found that this angle is 83. And we're not relating that other question to this guy, but the numbers are the same. So if we're looking for this missing angle, these two, right, add up to 83. And we know these two are a linear pair, so together they have to add up to 180. So 83 plus what equals 180? 97. Well, think about that. Look, I have this triangle here, this guy that looks like this. Oops. And I extended one side. This is an exterior angle. Angle 1 is an exterior angle. So I'm not looking at this angle next to it that's touching it. I'm looking at the other two. If I add those together, they add up to this outside exterior angle. So these two add up to this guy, right? So that's 97 degrees, C for number 11. That's the exterior angle theorem. Number 12 looks super long, and it's not. It's actually pretty easy. So here, I want to start comparing sides. It says, show the polygons are congruent by identifying all congruent corresponding parts, then write a congruent statement. So I want to start out each individual side, each individual angle. I got to name all the corresponding parts. So I'm going to start with the angles. Angle A has one little mark. Over here, angle D has one little mark. So if I look in my answers, angle A and angle D, perfect. Angle A and angle, that's already wrong, so I can mark that guy out. Angle A is not congruent to angle S. It's only congruent to angle D because they're marked congruent. Angle A and angle R, that one's out. Angle A and angle D. Okay, perfect. So I'm down to these, the top and the bottom, these two. So then I move on to the next angle. Angle B, it's got two little marks. Which angle over here does? Angle R. So angle B is congruent to angle R. Angle B is congruent to, that one's wrong too. Hey, look, we're done. Now we got our answer, right? Angle A is congruent to angle D. B is congruent to angle R, which means C and S have to be congruent. AB is congruent to RD, correct? DR, RD, same thing. BC and RS, here's BC, it's got two little lines. RS has two little lines, which means AC, which has 3 lines, is congruent to SD, which has 3 lines. AC and SD, DS, same thing. So these are all correct, which means triangle ABC is congruent to triangle DRS, correct, A. Easy peasy. Number 13, find the measure, classify each triangle in the figure by its angles and sides. So triangle ABD, which is this guy right here. Right? And all we notice about this triangle is that all of the sides have these little, I marked over them, they all have these one little hash marks, which means all 3 sides are equal. And if all 3 sides are equal, all three angles have to be equal because there's a relationship between a side and the angle it's across from. Remember that? So it's equiangular and equilateral, A. Two more. Number 14, oh, we're back to this guy again. On your multiple choice test assignment for this lesson or this review, all these same pictures are supposed to be put together. I hope they are. There might be one or two that's not. Okay, number 14, measure of angle 6. So we're looking for this guy right here, but guess what he is? An exterior angle, right? We took this triangle and we just extended one of its sides to create an outside angle. So we're not looking at the angle touching that outside angle, we're looking at the other two. If we add up the other two, they're gonna add up to angle 6. So 65 plus 82 equals 60 and 80 is 140, 5 and 2 is 7, so 147, A. And then the measure of angle 4 for the next problem, and angle 4 is this inside guy here. And we showed earlier, we probably should have had this one before that, but to find the measure of angle 4, we have a straight line right here, right? It looks like this, and it's got this guy, and this guy's 70, and then we've got angle 4, and then this guy is 65. So we know all three of these have to add up to 180 degrees, right? So 70 plus 65 plus whatever angle 4 is adds up to 180. Minus 135. Was that 45? Yep. 45A. Okay, hopefully you guys will do well with your review. If you have any questions at all, please give me a call or send me an email or a Schoology message, and I'll be happy to help you out with it.